So hello my dear students, today in this class we have discussed about the criteria for similarity of triangles. Okay, in last class you already learned about what is the criteria for similarity of triangle. Okay, if the two triangles are similar, okay, the two triangles are similar if their corresponding angles are equals to each other and their corresponding sides are in the same ratio or same proportion. Is it right? So now see here, this is theorem. Okay, theorem, it is depending on the criteria for similarity of triangle. Okay, these which criteria? This is angle, angle and angle. So three angles of the two triangles. Okay, so three angles, three corresponding angles are similar or equals to each other. At that time we can say these two triangles are similar. Okay, next see here the statement of theorem. If any two triangles, okay, if any two triangles corresponding angles are equal, okay, corresponding angles are equal, three corresponding angles are equal, then their corresponding sides are in the same ratio. Okay, then their corresponding sides are in the same ratio and have the two triangles are similar. Okay, what it means? If any two triangles having their corresponding angles are equal to each other, then they automatically the remaining three corresponding sides are must be or should be equal in ratio. Okay, so that this concept now we have to prove here. Okay, so next see here, consider. Okay, first we have consider how to take if in two triangles. Okay, so now take two triangles. Okay, any two triangles. Now I take this triangle ABC, and this is triangle DE. Yeah, okay, these are the two triangles. Consider these are the two triangles. See here, in triangle ABC and triangle DEF. Consider a triangle ABC and DEF. Okay, DEF. But they given here corresponding angles are equal. So I have to write here the given data. Okay, the given data, three angles are, the corresponding three angles are equal. So this is corresponding angles. Okay, A is corresponding to angle B, angle B is corresponding to angle E, and angle C is corresponding to angle F. Okay, they are already given. So angle A is equal to angle E and angle B is equal to angle. Okay, this equation called as equation number 1. The next, angle B is equal to angle E. Okay, it's called as equation number 2. And angle C is equal to angle F. It is called as equation number 3. Okay, so now what we have to prove in that theorem? Here, then their corresponding sides are in the same ratio. Now we have to prove their corresponding sides are in the same ratio. Okay, so to prove that, okay, TPT means to prove that the side AB, okay, the side AB is corresponding to side DE. Okay, side AB is corresponding to side DE is equals to the AC, side AC is corresponding to DF. AC side corresponding to DF, and this ratio is equals to BC is corresponding to EF. Okay, now see here, these corresponding sides are same or equal in ratio. Okay. So now here to prove that, okay, now we're going to prove this theorem. Okay, or proof. You can write proof or proof. Next, see here in triangle A, B, C, and D, E, F. Okay, construct or you can write directly here. Okay, construct line PQ in triangle, which triangle? This triangle. Okay, DEF in triangle DEF. Okay, construct a line PQ in triangle DEF such that here AB is equals to, now first we have to construct one line, okay, PQ, okay, then such that AB is equals to DP, okay, this equation we can call as a equation number 4, and AC is equals to DQ. This equation we call as a equation number 5. Okay. Now see here, equation number 1. Okay, observe equation number 1, equation number 4, and equation number 5. Equation 1, 4, and 5. See here, the first equation, the corresponding angles are equal, and equation number 4 and 5, the corresponding sides are equals to each other. Okay, see here, AB is equal to DP and AC is equal to DQ. So what it means? There, the two sides and one angle, the two corresponding sides and one corresponding angles are equals to each other. Okay, then why? Then here we can write the triangle ABC and triangle DPQ are congruence. Is it congruence? Yes. Why? So congruent sign is like that. Okay, so it is congruence to each other. Why? Because the which criteria it is? Side angle side criteria. Okay, side angle side criteria. Right, so that's why we can call as the triangle ABC and triangle DPQ are congruence to each other. Is it right? Now see here, when the two triangles are congruence, their all corresponding angles are equals to each other, and their all corresponding sides are equals to each other. Is it right? So now see here, the triangle ABC and triangle DPQ are now congruence. So the corresponding angle B, the angle B is corresponding to angle P are equal or not? Yes, because these two triangles are congruence to each other. So that's why here the angle B is equals to angle P. Is it right? So you can write here angle B is equals to angle P. Why? Because corresponding parts of corresponding triangles are equals to each other. Is it right? So this equation we can call as a equation number 6. Now similarly here, angle C is equals to angle Q. Why? because the two triangles are congruent to each other. Is it right? So the angle C and angle Q. Angle C is equals to angle Q. It is also CPCD. Okay, this is equation number 7. Is it right? Now see here, from equation 2, 3. Okay, the equation number 2, 3 and equation number 6 and 7. Equation number 6 and 7. See here, angle B is equal to angle E, and here angle B is equal to angle P. So obviously angle B is equal to angle P. Is it right? Or angle E is equal to angle P, because the angle B is equal to angle P and angle B is equal to angle E. So therefore here angle P is equal to angle E. Is it right? So write here angle B is equal to angle P is equal to angle E. This is equation number 8. And next, similarly angle C is equal to angle Q. Angle C is equal to angle Q, and angle Q is equal to angle F. Angle F. Okay, so this equation we can call as the equation number 9. Is it right? So now see here, from equation number 8 and 9, their corresponding angles are equals to each other. So we can call as a side PQ is parallel to AF. Is it right? So write here, side PQ is parallel to EF. Is it right? So now this triangle, okay. So triangle BEF, now we apply which theorem? Thielen's theorem or basic proportionality theorem. Is it right? So apply here, okay. So what is the Thielen's theorem? Thielen's theorem says the one side is draw parallel to any one side of the triangle. Okay, one line is draw parallel to any one side of the triangle. The remaining two sides are divided into equal two parts in the same ratio. Is it right? So that's why DP divided by PE. Right? DP divided by PE is equal to DQ divided by QF. Right? DQ divided by QF. Is it right? So next, these two ratios now rearranging in inverse. Okay, so their inverse. PE divided by DP is equals to QF divided by DQ. Okay, can you write like this? Yes, because now we inverse both hand side. Okay, left hand side also and right hand side also. Is right? So now adding one on both side. Okay, if see here, if this is A is equal to A. Is it right? Or you can take 3 is equal to 3. Now we adding 1 on both sides. Here 3 plus 1 is equal to 3 plus 1. So 3 plus 1, 4 is equal to 4. Means both left hand side and right hand sides are equals to each other. Okay, but their values doesn't change. Okay, left hand side is equal to right hand side. So therefore we can add 1 on both sides. Okay, see here, PE divided by DP plus 1, or first we have to write here, add 1 on both sides. This is the inverse of basic proportionality theorem or inverse of Thielen's theorem. Is it right? Next here, PE divided by DP plus 1 is equal to QF divided by DQ plus 1. So take LCM DP, okay, divided by 1 we can take. So the LCM of DP and 1 is DP. And next here, PE plus DP is equal to the LCM of DQ and 1 is DQ. Next QF plus DQ. Is it right? Next, now see here, PE plus DP. See here, PE plus DP or DP plus PE is equals to DE. Is it right? Is it right? DP plus PE is equal to DE. So you can write here DE. DE divided by DP, right, as it is equals to QF plus DQ. QF plus DQ or DQ plus QF is equals to DF. Is it right? So now we can write here DF. DF divided by DQ. DF divided by DQ. Is it right? Now see here, from the equation number 4 and 5. Okay, from the equation 4 and 5. Okay, see here very carefully. AB is equal to DP. See here, AB is equal to DP. So now we can replace the value of DP as AB. Is it right? So right here, DP right as it is, and DP now replace the value of AB because the value of DP is equals to the value of AB. So we can write here AB is equals to DF right as it is, DF right as it is, and DQ. See here, DQ is equal to AC. You can write here AC. Is it right? So now see here, what I have to clear, AB divided by DE is equals to AC divided by DF. Okay, now we take inverse. So now here, AB divided by DE is equals to AC divided by DF. Right? Now, see here, remember, if the two sides of corresponding sides are equal in same ratio, the remaining one side is always and equal to that ratio. Is it right? The remaining one side of the triangle is always in the same ratio of that two corresponding sides of this ratio. Okay, so that's why this equation is equation number 10. Okay, is it right? So here, in triangle ABC, in triangle ABC and in triangle DEF and DEF, from equation number, lastly we have to write the reason equation number 4. Now here AB divided by DE is equals to AC divided by DF is equals to the remaining sides are always in the same ratio. Okay, so BC divided by EF. So BC divided by EF. Okay, the new reason, the equation number 10. Okay, so hence proved the corresponding sides are in the same ratio. Okay, corresponding sides are in the same ratio, and that's why now we can say that the two triangles are similar. Okay, so hence the corresponding angles are equal to each other and their corresponding sides are in the same ratio. That's why the given two triangles are similar. Okay, so please note down this solution. And now we go into the next theorem. Okay, this is which criteria it is? AAA means the angle of the two triangles. Okay, please note down this. And now we shall start here. Okay.